For our next join example, we incorporate the ages table to demonstrate combining multiple tables using both left join and inner join. Here is the query. Select n.id, h.id, n.name, n.city, h.color, a.age. From names as n. Left join hair_color as h on n.id equals h.id. Inner join ages as a on n.id equals a.id. In the select clause, we added a.age to include the age column from the ages table. A new inner join clause was introduced, inner join ages as a on n.id equals a.id, linking the ages table to the names table based on matching ID values. This query is written to prioritize clarity and maintainability. Structured layout. The select clause clearly lists all desired fields, making it easy to see the output structure at a glance. Primary table. The from clause specifies names, aliased as n, as the primary table, serving as the foundation for the joins. Organized joins. The left join and inner join clauses are listed sequentially, each with a clear on condition to define the relationship between tables. Aliases. Using short aliases, n, h, a, keeps the query concise while maintaining readability. Readability. By aligning clauses vertically and using consistent indentation, the query is easier to read, understand, and debug. Additional notes. Join order. The left join ensures all records from names are included, even if there is no matching record in hair_color. The inner join with ages requires matching records, so only names records with corresponding ages entries appear in the result. Best practices. Always use aliases consistently and ensure on conditions are explicit to avoid ambiguity. For complex queries with multiple joins, consider commenting each join to explain its purpose. Writing queries in this structured, readable format not only makes your SQL easier to maintain but also helps collaborators quickly grasp the query's intent. Inner join ages as a on n.id equals a.id. What it does, the inner join retrieves only rows where the ID in the names table, n.id, matches the ID in the ages table, a.id. This means only records with a match in both tables appear in the result set. Key behavior. If no match is found in the ages table for a given names record, that row from names is excluded from the final result. Example impact. As shown in the ages table, next slide, there is no record for ID equals 3. Therefore, any names record with ID equals 3 will not appear in the result set. Why it matters. Unlike a left join, which keeps all records from names, with null for unmatched hair_color or ages data, the inner join enforces a stricter match, ensuring only complete data is returned. Additional notes. Use inner join when you only want records with valid matches across tables, such as generating reports where complete data is required. Contrast with left join. In the same query, the left join with hair_color ensures all names records are included, even without a matching hair_color. The inner join with ages filters out any names records missing an ages match. Tip: always verify the data in join tables to anticipate missing matches and understand the impact on your result set. In this slide we see the command from slide 1 and the result set. The query returns 2 rows, reflecting matches based on the left join with hair_color and inner join with ages. The first row, ID equals 1, has matches in all tables, names, Alice New York, hair_color, blonde, and ages, 25. The second row, ID equals 2, has matches in names, Bob, Los Angeles, and ages, 30, but no match in hair_color, so h.id and color are empty, null, due to the left join. Why only 2 rows? The inner join with ages excludes any names records without a matching ID in the ages table. This explains why ID equals 3 is missing. You can also see the ages table on the slide. The ages table has no record for ID equals 3. This is why no row with ID equals 3 appears in the result set, as the inner join requires a match. In a previous video, ID equals 3 was intentionally omitted from the ages table to demonstrate the filtering effect of inner join. ID equals 4 is not included in the names table, so it will not be included in the result set. The left join with hair_color keeps all names records, showing null for unmatched hair_color data, like Bob's row. The inner join with ages ensures only names records with a matching age are included, excluding ID equals 3 or any other unmatched IDs. Understanding these join behaviors is critical for controlling which data appears in your results and handling missing data effectively. Understanding full outer join. The full outer join, or full join, is a powerful SQL operation that returns all rows from both tables, regardless of whether there is a match in the other table. For rows without a match, the result includes null values in the columns from the unmatched table. Key characteristics. Comprehensive inclusion, unlike inner join, only matching rows, or left join, all rows from the left table. Full join ensures no data is excluded, making it ideal for comparing datasets or identifying gaps. Null handling, non-matching rows from either table appear with null in the columns of the table where no match exists. Use full join to analyze discrepancies between tables, such as finding records in one table that do not exist in another, or to combine datasets while preserving all data. Let us examine the following query, which combines the names, hair_color, and ages tables. Select n.id, h.id, n.name, n.city, h.color, a.age. From names as n. Left join hair_color as h on n.id equals h.id. Full join ages as a on n.id equals a.id. How it works. Step 1, the left join between names, aliased as n, and hair_color, aliased as h, includes all rows from names. If there is no match in hair_color, hair_color.id and hair_color.color are null. Step 2, the full join with ages, aliased as a, includes all rows from the result of the left join, as all names records, with hair_color matches or null. All rows from ages, even if they do not match an ID in names. For unmatched ages rows, names.id, names.name, name.city, and all hair_color columns are null. Best practices. Consistent syntax, choose either full outer join or full join and stick with it throughout your project. The same applies to left outer join or left join. Consistency improves readability and maintainability. Clear aliases, use short, meaningful aliases, like n, h, a, to keep the query concise while ensuring clarity. Comment complex queries. For queries with multiple joins, add comments to explain each join's purpose, especially for full join, which can produce complex outputs. Full join is a versatile tool for data analysis, especially when you need to see all records from both tables, including mismatches. Understanding its behavior, especially in combination with other joins like left join, helps you craft precise queries and handle missing data effectively. Always verify your table data and test your queries to ensure the results align with your expectations. Important note: MySQL, MariaDB, and SQLite limitations. Full join is not supported in MySQL or MariaDB or SQLite. If you are using these databases, you will need a workaround, such as combining left join and right join with a union to mimic full join behavior. However, be cautious. Many online union-based solutions are incomplete or incorrect, as they may miss edge cases or produce unexpected results. Testing is critical when implementing such workarounds. I have not personally verified a union solution for this purpose, but I plan to explore it further and maybe share a reliable approach on my blog under feedback and inquiries once this course is complete. For now, if you are using MySQL, MariaDB, or SQLite, consider restructuring your query or using a database that supports full join, like Postgres or SQL Server. I strongly encourage you to experiment with different databases to see how each handles operations like this. It is in your own interest to get familiar with different types of databases, not only for full join, but in general. When you start experimenting, you will discover what each database offers or lacks, deepening your SQL expertise. From names, the names table, aliased as n, is the base table, serving as the starting point for all joins. All rows from names are included in the query, forming the foundation for subsequent joins. Left join hair_color as h on n.id equals h.id, left join is performed between names, n, and hair_color, h. This includes all rows from names, even if there is no matching row in hair_color. Performs a left join between names, aliased as n, and hair_color, aliased as h, matching rows where names.id equals hair_color.id. This includes all rows from names, even if there is no match in hair_color. For unmatched rows, hair_color.id and hair_color.color are null. If Bob, id equals 2, has no hair_color record, his row still appears with hair_color.id equals null and hair_color.color equals null. Then we get the full join ages as a on n.id equals a.id performs a full outer join between the result of the left join, names and hair_color combined, and the ages table, aliased as a. Matching where names.id equals ages.id. From the left join result, all rows from names, with hair_color matches or null, are included. If there is no match in ages, ages.id and ages.age are null. From ages, all rows from ages are included, even if they do not match an ID in names. For unmatched ages rows, all names and hair_color columns are null. How rows appear in the result. Names rows with matches in both hair_color and ages, all columns from names, hair_color and ages, are fully populated with data. Names rows with a match in ages but no match in hair_color, hair_color.id and hair_color.color are null, while names and age columns are populated. Names rows with a match in hair_color but no match in ages, ages.age is null, while names and hair_color columns are populated, if present in the left join result. Ages rows with no match in names, all names and hair_color columns are null, while ages.age is populated. The left join ensures all names rows are included, and the full join ensures all ages rows are included, with null filling gaps for unmatched data. This query captures almost every row from all three tables, making it ideal for analyzing complete data sets. Replacing full join with left join. Let us modify our query by replacing the full join with a left join to see how it affects the result. Select n.id, h.id, n.name, n.city, h.color, a.age. From names as n. Left join hair_color as h on n.id equals h.id. Left join ages as a on n.id equals a.id. What changed? From full to left, the query is nearly identical to the previous one, except we replaced full join ages with left join ages. Impact on results. Full join included all rows from both names, with hair_color matches or null, and ages, with null for non-matching rows in either direction. Left join now includes all rows from names, with hair_color matches or null, but only ages rows that match names. Unmatched ages rows, like ID equals 4, are excluded from the result. The left join prioritizes the names table, omitting ages rows without a corresponding names record, unlike the full join's inclusive approach. I consistently use left join instead of right join, and here is why. Predictability. Sticking to left join makes queries easier to read and reason about, as the left table, like names, is always the anchor. There is no need for right join. Left join and right join are functionally equivalent. You can achieve the same result by swapping the table order. For example, A, right join B, is the same as B, left join A. Choosing left join simplifies your workflow. Avoid confusion, mixing left join and right join, or even left outer join and right outer join, in the same query can make it harder to follow. I have seen queries that flip between join types, likely from copied code or inconsistent styles, and they are a nightmare to debug. My advice, pick left join and use it consistently. It streamlines your queries, improves readability, and reduces errors. See the next slide for a side-by-side comparison of the full join and left join query output, to understand their differences in action. On this slide we see a visual representation of the difference between the full join and the left join. The top part of the screen shows our first query, the full join. Below it is the same query, but with a left join instead of the full join. Our names table has 3 rows. We perform a left join, names on the left, hair_color on the right, so all rows from the names table are included in the result. We see the ID column from names with values 1, 2, and 3, Alice, Bob and Carol, and 3 cities. The ID from hair_color, the second ID column, shows 1 and 3, ID 2 is missing from the hair_color table. As you can see in the color column, there is no hair color for Bob, he has ID 2 that is missing from that table. In the first query we do a full join on ages, that means we get all results from the left join. Again, Alice, Bob and Carol, ID 1, 2 and 3. And we also get all results from the ages table. We see ages 25, 30, and 40. We have no age for Carol, ID 3 is missing from the ages table, so the value is empty, or null. We do have an age of 40 that does not belong to a name. The result is: Alice has an age of 25. Bob has an age of 30. Carol has no age. Age 40 is added to the result, but it is not linked to a name or to a hair color. Let us now take a look at almost the same query where we changed the full join to a left join. What happens here is that only the result from the previous left join is displayed, and values from the ages table are added. So if there is a link from the left join result to the ages table, that age is displayed. Alice and Bob have an age added to the result set, and Carol has no value. The age 40 is not included in the result anymore. The main difference between full join and left, or right, join lies in how they handle unmatched rows from the join tables. Left join keeps all rows from the left table, names and its hair_color result, with null for non-matching ages rows. Unmatched ages rows, like ID equals 4, age equals 40, are omitted. Full join keeps all rows from both tables, names with hair_color and ages, with null for non-matching columns in either direction, including unmatched ages rows. Right join, not used here, would keep all rows from the right table, but as discussed, it is equivalent to left join with reversed table order. Use left join when you want to prioritize one table's rows as names and exclude unmatched rows from the join table, like ages. Use full join when you need every row from both tables, even unmatched ones, to analyze complete data sets.